Hello friends, I welcome you in lecture number 41 on basic statistics. In this lecture we are going to talk about regression. So first we understand why we require the need for regression analysis. So we have discussed about bivariate variables in earlier lectures. We have seen that if we have bivariate data with two variables x and y, then we can measure the degree of relationship between these two variables using coefficient of correlation, which we denote by r suffix xy or simply by r. Now suppose we want to find out or we want to predict value of one variable from the known value of another variable, then we will require some relationship between two variables which we can represent in mathematical form or in terms of mathematical equation, or we can have functional relationship between two variables. So the goal of regression is to find out or establish the functional relationship between two variables, so that if we know the value of one variable, we can predict the value of another variable. So that is the aim of regression. Regression analysis gives us the nature of functional relationship between two variables. So there are different types of relationships between two variables. That functional relationship may be linear or non-linear. Now suppose we consider this scatter diagram of two variables, then we can have this type of points in the xy plane. To find out the scatter diagram for the given bivariate data, we plot the values of two variables on x-axis and y-axis, and we find out these points in the xy plane. So if all these points are following this type of relationship, that is they fall near the straight line, then we can say that relationship is linear between two variables. So if values of x and y in this scatter diagram are falling near the straight line, then we can say that regression is linear regression. If the curve which all these points will tend to go near to that curve, if that curve is straight line, then we can say that regression is linear. But if the curve is not straight line, suppose we have this type of non-linear graph, and if the points which we consider in the scatter diagram tend to go towards this type of curve, then we can say that regression is non-linear regression. So in our course we are going to study linear regression. So in linear regression, the functional relationship between two variables will be y equal to fx, where this fx is linear function. So we can estimate the value of one variable from the another variable using the equation of straight line, which we know that y equal to a plus bx, where a and b are constants, or we can write x equal to a plus by. So in our course we are having only linear regression. So we will consider the straight line with slope b and intercept a, and our aim in this topic is to find out the line which is best fit for the given data. Okay, we can plot different lines from the given points. We can have this type of different lines, but we are interested in the line which will be best suitable line or line of best fit to the given data. So that line is known as line of regression of one variable on the another variable. So line of regression is the line which is of best fit to the given data. So depending on the dependency of given variables, if we have two variables, then we will have this type of situation. One variable will depend on the another variable. So we will consider one variable as dependent variable, another variable as independent variable. So in different problems we will have dependent and independent variables. Now if y depends on x, then we will consider this type of straight line y equal to a plus bx, and we will call this as line of regression of y on x. If x depends on y, then we will consider this form of straight line, and we will say that this is the line of regression of x on y. This equation of line is known as regression equation of y on x, and this is known as regression equation of x on y. So throughout this unit, our aim is to establish the linear relationship between given variables, or to find out the line of regression of y on x, or to find out the line of regression of x on y. And we know that a straight line can be represented in this form, y equal to a plus bx. So our aim is to find out values of these constants a and b, such that we obtain the best line of regression of y on x or line of regression of x on y. So now we are going to discuss how to find out these constants a and b. So there are different formulas for these constants in the line of regression. We will discuss all these things one by one. Before that, I have written certain things here. The goal of regression is to study the functional relationship between the variables and thereby provide a mechanism for prediction or forecasting. So prediction means if we know the value of one variable, and using that value of given variable, we can predict the value of another variable corresponding to that variable. For example, here I have written several variables. Suppose we denote this by y and this by x. So if we consider this first, the yield of a crop and rainfall, so we know that these two can be considered as dependent on each other. If we consider rainfall as independent variable, then from the given amount of rainfall, we can find out the prediction of the yield of a crop. Or suppose we consider this as independent variable, then we can predict the amount of rainfall required for the given yield of a crop. So in that way we can consider the relationship between two variables. Here another example is price of product and production and advertising expenditure, demand and price, expenditure of a person, and income. So we can say that expenditure of a person, if denoted by y, that depends on the income of a person. So from the given value of income, we can predict the expenditure of a person. So to find out all these types of prediction, we will use regression. Regression analysis provides estimates of values of the dependent variable from values of the independent variable. The device used to accomplish this estimation procedure is the regression line or line of regression. The line of regression is the line which gives the best estimate for the value of y for any specified value of x. In case of two variables x and y, we shall have two lines of regression as I discussed, one of y on x and the other of x on y. So our next discussion is how to find the line of regression. So for that, suppose we consider n points in the xy plane, or suppose we have this bivariate data. Values of variable x are x1, x2, xn. Values of variable y are y1, y2, yn. So we have n pairs of observations of the two variables x and y. Suppose we consider this y equal to a plus bx be the line of regression of y and on x. So here we are interested in the estimates for a and b, how to obtain values of a and b such that we can have y equal to a plus bx. So there are different ways of finding the line of regression of y on x or x on y. So one method is method of least squares. So we are not discussing this method in the detail here, but using this method of least squares, we will write down two equations for estimating these constants a and b. Those equations are known as normal equations. So how to write down that normal equations, that I will explain here. We have y equal to a plus bx line and we have n points. We have these n pairs x1, y1, x2, y2 and so on, xn, yn. So suppose sum of these x values is denoted by sigma x, sum of y values is denoted by sigma y. Similarly, we can multiply these values x1, y1, x2, y2 up to xn, yn, and this summation we will denote by sigma x. And we can find out square of x values, x1 square, x2 square, xn square, and this we will denote by sigma x square. Now we are not discussing the method of least squares, but I am explaining you how to write down the normal equations for these constants a and b using this line of regression of y on x. So first we consider summation on both sides of this equation and summation for all possible values of x and y. So if we consider sum of all values of y, we will denote that sum by sigma y equal to, here we have to sum these values. We are taking summation n times, so we will have a plus a n times. So that we can write as n into a plus sigma b into x. That means we are multiplying each value of x by b, and we will, if we take summation of all these values, bx1 plus bx2 and so on, bxn, then we can write down b common and we will have b times sigma x. So we will write down this summation as b times sigma x. So here I write n into a plus b times sigma x. So this is the first normal equation. Now to write down the second normal equation, first I multiply this equation 1 on both sides by x. So I will have x into y equal to a into x plus b into x square. Now again I take summation on both sides of all these values. So I consider summation of all these values x into y. So that summation I denote by sigma xy. Now as in the case of this sigma ax, that we can write as a times sigma x. So a times sigma x. Similarly, if we multiply each value of x1 square, x2 square by b, then sigma b x square will be equal to b times sigma x square. So we can write down normal equations from the given equation of straight line in this way. First we take summation on both sides of given equation. So we will obtain sigma y equal to a is taken sum for n times, so we have n into a plus sigma bx, that is b sigma x. Then we multiply this equation 1 by x and we obtain x into y equal to a into x plus b into x square. Now we take summation on both sides of this equation. So sigma xy equal to sigma ax, that is a sigma x, plus sigma b x square, that is b times sigma x square. So in this way we can write down the normal equations. Now we can find out solution of these two normal equations. Here we will consider a and b as variables and we can find out the solution of these two normal equations. For example, if I want to find out solution of this equation, suppose I want to eliminate a, then here I will multiply first equation by sigma x and I will multiply second equation by n, so that I will have n a sigma x and then I will take subtraction. Similarly, I can obtain value of b. So that is the idea of method of least squares. But we are not going to derive all these things. We will just remember that normal equations for estimating a and b are sigma y equal to n into a plus b sigma x, sigma xy equal to a times sigma x plus b sigma x square, and I have explained how to write these normal equations from this line of y on x. So if we solve these equations 2 and 3, we will obtain these expressions for these constants a and b. B will be equal to n times sigma xy minus sigma x sigma y divided by n times sigma x square minus sigma x whole square. A will be equal to sigma x square times sigma y minus sigma x sigma xy divided by n times sigma x square minus sigma x whole square. So you can see denominator remains same. If you don't want to remember this, you can find out the solution of these two equations as I explained. First we can multiply this equation 1 by sigma x, equation 2 by n, and then we can take difference of equation 2 and 3 and we will obtain value of b. A will be eliminated. Similarly, we can obtain the value of a. So solving normal equations, we are able to obtain values of a and b. Now once we obtain values of a and b, we can substitute them in this equation and we will obtain line of regression of y on x. So this is one method for obtaining line of regression of y on x. This method is known as method of least squares. So for method of least squares, we have to first write down normal equations, and solving normal equations we will obtain values of a and b. Now in examination, if they specify that find out line of regression using method of least squares, then you have to use this method only to obtain the line of regression of y on x or x on y. But if method is not specified, then we have some shortcut methods for obtaining line of y on x or line of x on y. This method is not tedious if values of x and y are small or in a single digit. But if values of x and y are large, then this method becomes tedious. It is not comfortable to obtain this type of summations if values of x and y are large. So in that case, we have some another method also that we are going to discuss. But if you are specified that using method of least squares find out regression line, then you have to use this method only. So now after this obtaining values of a and b, you have to substitute these values of a and b in given equation 1. We obtain the regression line of y on x. So here this completes the method of least squares. Now what is another way of finding the line of regression? So that we are discussing now. So for that we are using again this normal equation 2. We divide both sides of this equation 2 by n. So on the left hand side I have sigma y, that I divide by n. Here I divide this by n, so I will have n into a divided by n, that is a, plus b times sigma x divided by n. So we can see this is sum of all y values divided by total number of values. So this is nothing but mean of y. Similarly, a plus b, this is sum of all x values divided by total number of values, so that is x bar. So we obtain that y bar equal to a plus b x bar. So we can see our line is y equal to a plus bx, and this point x bar comma y bar satisfies this equation. If we put y equal to y bar, x equal to x bar, this equation is satisfied, that we have obtained from this equation 2. So that shows that this point x bar comma y bar lies on the regression of y, lies on the line of regression of y on x. So here I have written, dividing both sides of 2 by n, we obtain this y bar equal to a plus b x bar. This means that the line of regression of y on x passes through the point x bar y bar, or we can say that this point x bar y bar lies on the line of regression of y on x. Okay, fine. So why we have done this thing here? Because we will require this in further discussion. So we will remember this, that line of regression of y on x passes through this point x bar y bar, or x bar y bar lies on the line of regression of y on x. We are going to use this fact. Now using equation 3, now in equation 3 we are shifting the origin to this point. Now we know that this point x bar y bar lies on the regression line. So now we are shifting the origin to this point in equation number 3. So for example, if I shift origin to this point x bar y bar, I can write down this left hand side of equation 3 as x minus x bar times y minus y bar. I will replace x by x minus x bar and y by y minus y bar. Similarly, this is going to be a times sigma x minus x bar, and this is going to be b times sigma x minus x bar whole square. So we are shifting the origin to the point x bar y bar in this equation number 3. Shifting origin to the point x bar y bar in equation 3, we have sigma x minus x bar times y minus y bar equal to a times sigma x minus x bar plus b times sigma x minus x bar whole square. Now this is the sum of deviations of x values from its mean, and we know that this summation is always 0. So we will obtain this equation, sigma x minus x bar times y minus y bar equal to b times sigma x minus x bar whole square. So from this I can obtain the value of b. Therefore b equal to sigma x minus x bar times y minus y bar divided by sigma x minus x bar whole square. So you can see we obtain the formula for this coefficient b, y equal to a plus bx, which is the slope of the regression line, and we obtain another formula for this coefficient b equal to sigma x minus x bar times y minus y bar divided by sigma x minus x bar whole square. Now we are not going to obtain the formula for a here, but we will simplify this line of regression of y on x, or we will write down this line of regression of y on x in another form. So for that, first we have obtained the value of slope of this line, b equal to sigma x minus x bar times y minus y bar divided by sigma x minus x bar whole square. Now we require this definition here again. We recall that the rank correlation coefficient between two variables x and y is given by r equal to covariance between x and y divided by standard deviation of x times standard deviation of y. Now we keep these two as it is and we write down the formula for covariance between x and y, that is sigma x minus x bar times sigma y minus y bar divided by n. So this is the formula for covariance between x and y. So from this we can obtain the expression for this. Sigma x minus x bar times y minus y bar will be equal to, we shift all these values on left hand side, n times coefficient of correlation times standard deviation of x times standard deviation of y. So now we substitute this summation in the formula for b, which we have obtained here. So we write down sigma x minus x bar times y minus y bar equal to n r sigma x sigma y in that formula of b. Now this I can rewrite as, I can write n as 1 divided by 1 by n. So I will obtain this term here, and this is nothing but variance of x, sigma x square. So now we have sigma x divided by square of sigma x. So we have r times sigma y over sigma x. So here also we obtain another formula for the coefficient b in the line of regression of y on x. Okay, this is slope of this line. So we have this formula, y b equal to sigma x minus x bar y minus y bar divided by sigma x minus x bar square, and using rank correlation coefficient we obtain another formula for that slope, y b equal to r times sigma y over sigma x. Now in this line y equal to a plus bx, this b represents the slope of the line of regression of y on x. Now we can write down this equation in another form also. If you remember that if we know the slope of the line, suppose slope of the line is m, and suppose line is passing through some point, say x1 y1, then we have this equation y minus y1 equal to m times x minus x1. Equation of a line with slope m and point x1 y1 in which it is passing is given by y minus y1 times m y minus y1 equal to m times x minus x1. Now we have established that this regression line passes through the point x bar y bar, and if we write in this form, then this b is the slope of the line, and we have this formula for slope, that is b. So in this equation we will consider x1 y1 equal to x bar y bar, our m is b and x1 is replaced by x bar. So we obtain another form of the line of regression of y on x. We have proved that this line passes through the point x bar y bar. Hence, using the slope point form of the equation, this form of equation of straight line is known as slope point form. Using this slope point form of the equation of a line, the equation of the line of regression of y on x becomes y minus y bar equal to b times x minus x bar, and we have this formula for b equal to r times sigma y by sigma x. So that we substitute here. So we obtain another form for the regression equation of y on x, or for the line of regression of y on x. So if we know all these values, r, coefficient of correlation, standard deviation of x, standard deviation of y, then we can use this formula, or we can use this formula to obtain value of b equal to sigma x minus x bar times y minus y bar divided by sigma x minus x bar whole square. So we have different methods to find out the line of regression of y on x. Depending upon the situation of given problem, we will decide which formula we have to use. So that we will discuss in upcoming lectures. We will discuss the problems of finding regression line of y on x in upcoming lectures, and we will decide that how to use appropriate formulas in different situations. So this equation number 7 is known as regression equation of y on x. Now this slope b is given particular name. It is known as regression coefficient of y on x. If we have y equal to a plus bx, if we have line of regression of y on x, then this b is known as regression coefficient of y on x. It is denoted by b suffix yx. So we have shown that byx can be given by r times sigma y by sigma x, or byx can be given by sigma x minus x bar times sigma y minus sigma x minus x bar times y minus y bar divided by sigma x minus x bar square. And we have also shown that b can be given by this formula also. Okay, so we have three formulas for obtaining this constant b, y equal to a plus bx, where b can be given by this formula using method of least squares, or we can obtain b using this formula, or we can obtain b using this formula also. Now suppose we are interested in the line of regression of x on y. So for that we have the same procedure. So, but we will not derive all these things. For the line of regression of x and y, we have to just interchange x and y in all these formulas. Suppose we want to write down the formula for line of regression of x and y, then we will interchange x by y and y by x in all these formulas. The line of regression of x and y, x on y, can be obtained by interchanging x and y in the line of regression of y on x. So the line of regression of x and y is x equal to a plus by, or we have x minus x bar equal to r times sigma x by sigma y, y minus y bar. We have seen that line of regression of y on x is given by r times sigma y by sigma x times x minus x bar. This is line of regression of y on x. So in this equation we interchange x and y to write down the line of regression of x and y. So here I have y minus y bar, so that I replace by x minus x bar. R remains as it is. This sigma y is replaced by sigma x is replaced by sigma y, and y minus y bar is replaced by x minus x bar. Here this coefficient is called regression coefficient of y on x, and here we will call this as regression coefficient of x on y, and we will denote it by b suffix xy. bxy will be equal to r times standard deviation of x divided by standard deviation of y, and is called the regression coefficient of x on y. So these are the formulas for regression coefficient of x on y. bxy equal to sigma x minus x bar times y minus y bar divided by sigma y minus y bar whole square equal to r times sigma x by sigma y. So we will remember these formulas for this regression coefficient of y on x only, and regression coefficient of x and y can be obtained by interchanging x and y in these formulas. Now we make one remark. Now we know that regression coefficient of y on x is given by r times standard deviation of y divided by standard deviation of x, and this we write by replacing y by x and x by y in this formula. Now if we take product of these two, this and this, then we will see that r into r, that is r square, and this sigma y and sigma x will cancel each other. So we can see that product of regression coefficients equal to square of correlation coefficient. We can write this as r square equal to byx times bxy, or we can see that r can be written as square root of byx into bxy. So now byx into bxy, there are two possibilities. We can have positive or negative square roots. From this we can see that this r is the geometric mean of regression coefficients. Now because we have r square equal to byx into bxy, so from this we can say that because r square is always non-negative, so there are two possibilities. This byx and bxy can be positive, both can be positive, or both can be negative. Okay, we cannot have the situation that one is positive and another is negative. If one is positive and another is negative, then r square will be negative. That is a contradiction. So either both the regression coefficients will be positive or both the regression coefficients will be negative. Now problem is which sign we have to take for this coefficient of correlation. So we will remember that if both regression coefficients are positive, we will consider correlation coefficient as positive. That is, we will consider positive square root. And if both regression coefficients are negative, we will consider coefficient of correlation as negative. So sign of correlation coefficient will depend on the sign of regression coefficients. If both regression coefficients are positive, r is positive. If both regression coefficients are negative, r is negative. So here I have written the sign of r is taken positive if both regression coefficients are positive, and same thing for negative. Okay, fine. So in this lecture we have discussed how to obtain line of regression of y on x, or we call this as regression equation of y on x. We will remember both the terms. This is known as line of regression of y on x or regression equation of y on x, and it is given by y equal to a plus bx, or another formula is y minus y bar equal to byx times x minus x bar. And we have seen different ways of obtaining this regression coefficient. So this we obtain using the method of least squares. Here we have used that normal equation, using two normal equations, and this is relationship between regression coefficient and correlation coefficient. So in which situation we have to use all these things, that we will discuss in upcoming lectures, and we will remember that this we will use if it is specified that we have to solve the problem using method of least squares. This method is helpful if we have small values for x and y, that is single digit values. But if we have large values for x and y, then it is not advisable to use this formula. The work will be tedious and time consuming. So if nothing is specified, we can use either this or this. So we will discuss in the next lecture this type of problems of obtaining regression lines. So this is all about this session. I hope you like it. Thank you.